Hello, Charter family. This is Miss Boyd at Mrs. Boyd's Math Room. Today, we'll be talking about tests for parallelograms. It's nice to put some testing on some math every now and then, and we're going to do that today. All right, if a quadrilateral has each pair of opposite sides parallel, it is a parallelogram by definition. That's what a parallelogram is. If it has only made up of sides where opposite sides are parallel, it's a parallelogram. If we don't know for certain, if we're not told in a problem that that is true, we can use one of the following four tests. If both pairs of opposite sides are congruent, it's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. If the diagonals bisect each other, it's a parallelogram. Let's fix this. Each doesn't look like a word. Last but not least, if one pair of sides is both congruent and parallel, it's a parallelogram. So let's keep those 4 points in mind while we look at the following figures to see if they are parallelograms. We'll call this number one. Number one, is that a parallelogram? Take a look, write down what you think or think it in your mind. This is yes. We use test number one that says that if both pairs of opposite sides are congruent. So 8 and 8 are congruent, 5 and 5 are congruent. So these have to be parallel lines and parallelogram. Number two, we're given that opposite angles are congruent, 85 and 85. And we're given that one pair of opposite sides are congruent. Well, let's look at what we need to know. We need to know that both pairs of opposite sides are congruent. We don't know about this side or this side. We need to know that both pairs of opposite angles are congruent. We know about these two. We don't know about those two. Or we need to know one pair of sides is both congruent and parallel. We know nothing about this. So no, we cannot prove this is a parallelogram. We don't have enough information. Okay, we have to know a certain list of things, and if we don't know enough, we can't make a decision. Number three, we know that the opposite two sides here are congruent. So that's one thing we need to know. We also can see that the two consecutive angles here on this side are supplementary because we can take 100 plus 80 and get 180. If those two consecutive interior angles are supplementary, then these two lines have to be parallel. So we can say, yes, this is true because test number four. One pair of sides is both congruent and parallel. All right, number four. We know that this side and this side are congruent, or this angle, so sorry, and this angle and this angle are congruent. So we can say, yes, this is a parallelogram because of test Number 2, because if both pairs of opposite angles are congruent, then our figure is a parallelogram. 2 more. All right, number 5. We've got this figure. Let's look at this diagonal first. This one has a length of 5, then this one has a length of 5. So that means that this diagonal has been bisected. The other diagonal, this one has a length of 3, and this one has a length of 4. So these two lengths are not congruent, which means this has not been bisected. So this is not a parallelogram because of test number 3. Both diagonals have to bisect each other, not one or the other. Last one, number 6. Sorry, gotta get caught up here. All right, we've got opposite sides are the same length, 5 and 5 on either side. We know that one of these diagonals is bisected. We don't know anything about the angle measures. We don't know anything about these two sides, and we don't know anything about these two parts of the other diagonal. So this is a no. We cannot tell if it's a parallelogram because we don't have enough information again. We need something about the lines being parallel. We need something about the diagonals being bisected or the angles being congruent. But as it stands, we cannot tell anything about that figure, if it's a parallelogram or not. So flip your paper on over. We want to determine if the figure is a parallelogram using the given strategy. Let's use slope. Let's graph our points first so we can see what we're dealing with. 0, 0 is A. B is at 1, 3. C is at 5, 3. And D is at 4, 0. Oh, it's a bad one. There we go. That's not too bad. All right. So if you'll think back in your brains to Algebra 1 and about what makes lines parallel, we've actually also talked about it this year so far. We know that parallel lines have equal slope, have the same slope, not slop. So if we find the slopes between the lines of opposite sides, then we'll be able to tell if they're parallel or not. So let's find the slope of segment AB. That's going to be y2 minus y1 over x2 minus x1, which is 3. Now the slope of CD is the line that might be parallel to that. So that'll be y2 minus y1 over x2 minus x1. That's -3 over -1, which is 3. So these lines are parallel. Let's do the other two opposite sides. The slope of BC, that is y2 minus y1 over x2 minus x1. That's 0 over 4, which is 0. Last one, slope of AD. That is x2 or y2 minus y1 over x2 minus x1, 0 over 4. That's 0 as well. So these two lines are also parallel. So we can say, yes, this is a parallelogram. Oh, yes. I don't even know. I can't even imagine what this might mean because opposite sides are parallel. Let's use slope and distance next to test our parallelograms and see if they are, if it is a parallelogram. Let's plot our points. -2, +4. -1, -1. Well, let's label them. A, B, C is 3, -4. And D is 2, 1. Mine is terribly drawn, but you get the picture. All right, slope and distance. Well, let's find the slope of line AD and BC and compare those. So the slope of segment AD is 1 - 4 over 2 minus -2, and that's 3/4. -3/4, so sorry, -3 on top. And then the slope of segment BC, that's -4 minus -1 over 3 minus -1. So that's -3/4 again. So these two lines are parallel. Now let's use the distance formula to find the distance of AD. AD, so sorry. Because we know that if our lines are both congruent and parallel on one side, then this is a parallelogram. So let's get started with this distance formula. We know we need a giant square root, and we'll do the difference of x's, so -2 minus 2 squared, plus the difference of y's, 4 minus 1 squared. That is the square root of 16 plus 9. I skipped some steps there. That is square root of 25, which is 5. Now we're going to do the distance of segment BC. That's the square root of the difference in x's. It's going to be 3 plus 1 squared plus -4 plus 1 squared. That's the square root of 16 plus 9. That's the square root of 25, and that is still 5. So AD and BC are also congruent. So we can say, yes, this is a parallelogram. One set of sides is parallel and congruent. Let's keep on keeping on. 2 more ways to look at this. We're going to look at just the distance formula now. Let's plot our parallelogram. -1, 0 is A. 3, 0 is B. 2, -3 is C. And -3, -2 is D. We're going to use only the distance formula to see if we have parallel lines. So let's find first the distance of AB, segment AB. It's the square root of the change in x's squared plus the change in y's squared. That is 4. It's going to be that distance. Now let's do the distance of CD. Opposite side, and make sure these match. You might already have an idea about what you think it's going to be, or not be, rather, but we have to prove it. So we've got -3 minus 2 squared plus -2 plus 3 squared. That is the square root of 25 plus 1. That's the square root of 26, which is definitely not 4. So we can say, no, these are not parallelograms. One set of opposite sides is not congruent. Last but not least, we're going to talk about midpoints here. And when we talk about midpoints, we don't mean midpoints of the my cat's trying to break everything I own. Don't mean midpoints of the sides. We mean midpoints of the diagonals. So if all the sides are parallel or congruent, the diagonals should have the same midpoint. Let's plot our figure here. A is at 3, 3. B is at 1, 2. C is at -3, 1. And D is at -1, 4. So I wrote B kind of in the middle there. Let me fix that. And connect these points. Sorta. Oh. So our diagonals are AC. So we'll want to find the midpoint of AC and the midpoint of DB. So midpoint of AC is going to be the difference of, or the sum of the x's. So 3 minus 3 over 2. And the sum of the, the sum of the y values. So 3 plus 1 over 2. So that midpoint is 0, 2. Should be where the midpoint is. The midpoint of DB, sum of the x's, which is going to be struggling. 1 minus 1 over 2. And the sum of the y's over 2. That is 0, 3. So we can see that 0, 2 and 0, 3 are not the same point. So we can say this is not a parallelogram because the diagonals do not have the same midpoint. I know this was a lot to remember, a lot of parts to this puzzle. Please let me know if you have any problems or need any help. You know how to get a hold of me. I look forward to seeing you soon.